I talked about how the robot can guide you along a path. So right now, these walls here are actually being rendered by the brakes. So I actually can't push through here. It'll stop me, but it allows me to go through the tunnel. So my name is Thomas Augenstein. I'm a PhD candidate in the robotics department at the University of Michigan. I work in Dr. Chandramoli Krishnan's neuro lab, where we focus on developing and validating low-cost rehabilitation robots for stroke rehabilitation, among other neurological or orthopedic injuries. A lot of rehabilitation robots meant to help people with arm function or leg function exist, but they're quite large, they're quite expensive, and that really hurts their accessibility. Those big, expensive devices use these high-powered motors to generate torques to assist or resist people's motion, and we remove those motors and look for lower-cost force generation elements. So computer-controlled brakes is a great example of one. We also use cables to couple motion, elastic bands. This is Separo. It's a tabletop device where somebody grabs the handle and they move it around the workspace using their shoulder, elbow, and wrist. And the robot is sensing where their hand is and where it's going and controlling brakes in real time to either resist or steer their motion. We can use that to alter muscle coordination in stroke survivors. So stroke survivors often suffer from what we would call synergies or abnormal coupling of torques between joints, and that shows up as abnormal muscle activity, right? So if we can use these steering forces to help them practice changing their muscle activity in the context of reaching for household objects, that's a big advantage, which can help in terms of relearning lost motor skills like writing a letter or drawing a shape. We also have the hand embot is what we call it, shorthand name for what we would call an embodied robot. An embodied robot basically means that the assistive power to the weaker side is coming from the stronger side. So we do that with Bowden cables, which are the same cables that you squeeze when you're riding your bike, you squeeze the brake, same cable. And when you couple that motion, basically what happens is now that impaired hand is receiving assistance, but it's also acting as a penalty on the stronger limb. I squeeze my hand here. That helps me grab the bottle. You know, because it has that self-power aspect to it, you know, it's both assistive, but it's also rehabilitative, right? It's meant to encourage me to activate my finger flexors and extensors more. It's just using the coupling to give this hand a little more of a boost. Another great thing about this is, you know, I could do a pinching motion as well, keeping those other fingers fully extended. You know, usually if you wanted to provide motorized assistance to each of these fingers, it would take, you know, that would lead to a very heavy device or a device that is anchored to a table. I work often with stroke survivors. We all know that if you train a lot, you practice a lot, you know, working on your arm and leg function after a stroke, the more you work at it, the more you recover. The issue is that when you have reduced third-party health insurance coverage, you can't always afford it. The goal with these devices is really to get something that somebody can afford or a clinic can afford so that we can really expand that dosage and help people who are currently not realizing their full recovery get there.